Thank you for joining us in our webinar today. We're going to get started in a few minutes as we wait for a few more attendees to trickle in. As for audio options, you can see on our slide that we have you can call in on your phone. The number and access code are listed, or you can use the audio on your computer. So we'll be getting started in just a few minutes. All right, well, I think we'll get started. Good morning, everyone. Thank you for joining us in our webinar on bringing Passive House to Yale First Nation. As I mentioned previously, you have two options for audio. You can listen in on your computer, or you can call in to the phone number and access code below. So this webinar is part of our First Nations Home Energy Save program. And through this program, the Fraser Basin Council is working with First Nations communities as well as support organizations to look at reducing energy use, specifically in residential housing, though we also do some work on community buildings. We often share stories about what communities are engaging with in energy efficiency, and our webinar series is part of how we do that. We also offer different learning events as well as an annual in-person workshop. And we also work to build community capacity in energy efficiency. On the slide, you can see our website. And if you want to find out more information about our program, you can go visit that site. So some logistics for the webinar. We keep everyone's audio muted just to limit background noise. If you want to ask any questions, you can see on the side panel, there's a question box. We save our Q&A session until the very end, but you can type into this question box. As well, if you have any technical difficulties, you can enter this in the question box, or you can send an email to fraserbasin@gmail.com. So for today's presentation, we are really fortunate to have two great speakers. First is Crystal Sedore. Crystal is the housing manager for Yale First Nation. She has worked on behalf of Fraser area First Nations communities for almost 20 years in many different capacities, from economic development to career development to housing. And for this presentation, she'll share Yale First Nation's journey towards sustainable housing and the innovative passive housing project going up on Yale Reserve lands. And our second speaker is Colin Doylend. So Colin is the Director of Indigenous Relations at Britco and has spent over 15 years working for First Nations communities on economic development as well as renewable energy projects. He has also worked with BC Hydro in their Corporate Affairs Department and the Ministry of Aboriginal Relations and Reconciliation as the Senior Assistant to the Minister. So at this point, I'm going to transfer the presentation control over to Crystal. So if you could bear with us for a moment.
Good morning. Thank you so much for joining us. I am here today in snowy and blowy Thunder Bay to present this presentation today, so I hope that you enjoy. I'll be talking about the importance of planning for sustainability within your housing department and investing today to meet the needs of tomorrow. So I'm just going to start here. So when I first started working for Yale First Nation, they had just had an election. There was a new chief and council in, and you know, they were shaking up the house. So this picture that you can see, this is very typical of what you will see on Yale Reserve lands, at least when we started anyway, 2 years ago. So we had to start by getting leadership in. So the community forced a secret ballot election. A new chief and council were elected. There were no policies, there were no rents collected, no home maintenance. There was no housing department. All of the staff and management were fired and qualified persons were hired. So we got off to a fresh start, and my first point of business was creating a housing department. So we had to start by finding some money. So that's where a new approach to housing came in for policy. And that got me into the office and got work started. And then we ended up with some capacity funding to support consultation through NRT, and that was for our community council. And CMHC also contributed to our housing budgets with internship funding through the HIFNI program. First I had to do is create housing files. When I walked in, housing was a file folder with about 5 sheets of paper in it. So that's where I started. Nobody knew who owned anything. Nobody knew who was paying, who wasn't paying. Nobody knew who was eligible for CP or whether they had even already CP'd their homes. So we started by writing housing policies. It took about 6 months. Those housing policies were ratified by Chief and Council and involved considerable community consultation through the community council funded by NRT. Then we did inspections. None of these homes had been inspected in about 25 years, nor had they had home maintenance. So we were really starting behind the 8 ball. So after the inspections, I created maintenance plans for every house on reserve. We have 13 right now, 13 rental homes, and then about a dozen that have been CP'd. I did a housing needs assessment to not only determine what we needed right away, but also to figure out what we needed in the future for housing for the kids who were entering into adulthood, any of the band members who might be reaching the age of retirement, who might be interested in coming home for their, for their twilight years, and then also to talk to some of our young adults who are out either in school or in seasonal employment, etc., and what their housing needs might be, whether it's seasonal, whether it's permanent, whether it's transitional housing even. So we did a quite detailed housing needs assessment and came up with a 5-year plan. Along with that plan came with a plan for new construction. We'll talk about that in a couple of minutes. So I wanted to talk to you about the housing that we had when I started. So the chief calls it a BC box, and I've heard a lot of other people call the traditional reserve houses BC boxes. This is what we put into this particular house in the last 2 years. Maintenance and repairs, 2015-16, 35,000. We did a renovation in 2015 with INAC mold funding in the amount of 23,700. Emergency repairs, you can't plan ahead for those. Plumbing and chimney, 2016, 9,000. And then pest extermination. It was an old house. There hadn't been housing policies. The carport that you're looking at there was stacked right to the rafters with cardboard boxes and garbage bags and recyclables and just straight out garbage. And so, you end up with those pests. You end up with ants and rats and mice, various bugs that we had to spray for, not only get rid of the bugs, but repair the damage that they had done into this house. So in the past 2 years, we've put in $68,700. With a potential revenue of $580 a month, you're looking at only a $69.60 revenue return on the house per year, which leaves us in the red in the amount of $61,740 for the past 2 years. And YFN has 13 of these houses, and they're all in very similar state. This, you can see, is a hastily dismantled grow-up. Massive plumbing failures and all of the damage that comes along with that. Leaking roofs and interior damage. This is just one patch. This particular house had about 2 dozen pots and pans up and down the stairs to catch the leaking water. This is one of the houses, very typical. We had single pane windows, broken windows. The broken front door had been kicked in multiple times and repaired. And then incomplete or inadequate repairs, and that usually by the tenant. Former leadership, not only were they not collecting rents, but they also weren't accessing any maintenance funding that might be available. And so repairs that usually were done were usually just, done by the tenants, whatever they could manage to do. You can see the screen that had been taped in at one point. More leaky plumbing, inadequate or non-existent ventilation. You'll hear the stories all the time about on reserve homes where the contractors vent right up into the attic. Doesn't even go through the roof. All 13 of our rental homes had that situation. They had the vents going up into the roof. And the significant interior damage that results from that type of moisture. The worst part is that we had contractors that we couldn't go back on them. Sure, we had written warranties, but those warranties are no good if the company's out of business or we don't have contact information for any of them. They've come and gone. More water damage from a leaking roof. This time it was affecting the electrical system. You can see the drips going down the wall. The brown bar across the top is the kitchen cupboards. And this was presenting a real health hazard for our tenant. We were worried not only about electrification, but we were also worried about the house catching on fire. A roof, failing roofs. So with holes like this in your soffits and fascia, you're going to be getting pests in there. We had birds, squirrels, bats, rats. We had our tenants smudging their homes because they thought they had spirits, and it was just the squirrels running around the attics. And then, of course, the water damage and the mold that results from this type of damage. We had mold present in 10 of the 13 homes. This is pretty typical right here, this picture of the mold. This photo was taken 1 week after I moved a young mom and her infant out of the house. I had to have First Nations Health Authority come in and do a health inspection, and he recommended that we condemn the house. And so we did. And we were given 24 hours to get the young mom and her baby out of the house. This is just one room. The other rooms were all very much the same. Here we are now. This is that same red house. Everything that we've put in here is with an eye towards long-term sustainability. So we used mold-resistant materials. We put in triple glazed windows. We made sure that everything was adequately ventilated, the kitchen, the bathroom, the laundry area. Every place where we might be generating some moisture leading to condensation, we put in ventilation. And we also had a tenant education strategy so that we talked to our members about how to keep their home moisture free, how to prevent mold, and also how to remediate it. If they see a little something starting, they know how to take care of that. But they also know that when they call housing, that housing is going to be there right away to take care of any problems they might have. So small leaks don't become big problems. So we were talking about new construction, and we asked ourselves, housing department spoke with chief and council, and we consulted for almost a year. And we said, what are we going to build? Because if something doesn't work, why keep doing it? Why keep building these big homes? We decided that what we needed was affordable housing that the band could afford, not just to actually build the house, but also to maintain it. We needed housing that was affordable for the tenant, and not just in terms of rent, but also in terms of operating the house, paying the hydro bills, paying the heating bills. We needed something that was going to be low maintenance, because we can't afford to be throwing $60,000 into a house every year. It's not sustainable. That would break the band pretty darn quick. We also talked about housing that's appropriate for the climate. There are bands, and we're one of them, who have built houses that are just not appropriate for the rainforest type climate that we live in. We have one house that has a stucco exterior, and it's rotted all the way from the ground up to 12 inches off the ground because that stucco just cannot handle the moisture. And the housing department should have thought of that before they built that house. We need to build something that's going to be appropriate to the climate of the Hope and Yale area. Also appropriate for the lifestyle of the tenants. It needs to be mold resistant, and there needs to be economy of space. When you're working with First Nations, you know that First Nations people, they like to cook rice, they like to do their canning, they like to process fish. And if you're building housing, you need to keep that in mind, that there's going to be quite a bit of steam and moisture generated in the home. And so we thought even about including taps outside in a flat area where people can process their fish and do their canning outside of the home. And that's all just part of planning for our tenants, planning for their future. And then we wanted something that's healthy and safe and comfortable. We also wanted housing that's going to be attractive. It's going to be nice to live in. But we also wanted a long-term relationship with our builder so that we have warranties. We have a relationship that will hopefully lead to cost savings in the long run, building by volume, having that expertise available to us when we need assistance with maintenance or with the systems of the homes. So we started talking about passive housing. It's relatively new. The chief said to me one day, "Do you know about passive housing?" And I said, "I don't have a clue what that is." And so we did a little bit of research about it, and we started talking with Britco, and we started talking with other companies that work in passive. But it seemed like we were leaning one way. So we looked at our site, and you can see the original site. That's what it looked like. And once we cleared the site and removed the home that had been condemned, we ended up with a beautiful, appropriate site that was already serviced. Hydro's right there to the line. The water goes right to the road. There's already an existing septic area there. Not that we could use it, but it was there if we needed it. And so we decided this is what we're going to do. We're moving ahead with Britco, and Colin will tell you more about this wonderful building that they built for us. In a matter of, I guess we're looking at 2.5 months, a little bit of weather delay, we went from that lot that you just saw to this. Step by step, they moved it in over a period of, I believe, 2 or 3 days. We went from a bare foundation to our units being moved in piece by piece on the crane, set down in place, and Colin takes it from here.
Perfect. Well, thanks, Crystal. I want to make sure that everyone can see the screen. There we go. Can everyone see the main screen?
Hi, Colin. Yes, we can see your main screen.
Perfect.
I'm hearing a little bit of feedback on your audio, though.
Okay. Is that better?
Let me unmute myself, and then maybe that will help.
Okay. All right. Well, thanks, everyone. We're proud to be a partner with the Yale First Nation as they deliver their new vision for affordable and sustainable housing. And it's been a pleasure to work with Crystal, because when you have someone like her with her skill and professionalism, there isn't anything we can't accomplish on behalf of nations. And this project that we're working on, I trust, is a good example of that. So with that, really wanted to get into what is a passive house, and why is it important, and why is everyone interested today to come take a look at this webinar, how it will make a difference in communities. And Crystal has shown the story about how it's going to affect Yale for the good, and I want to show a little bit more of those details. So in the past few decades, building technology has been developed in Europe called the passive house. That it basically drastically reduces household energy consumption and greenhouse gas emissions. So for the first time in Canada, Britco has applied modular techniques to passive house standards, and I'll walk you through the successes and how we are building the most energy efficient, affordable housing on reserve in Canada with Yale. Perfect. So as you can see, let's get back to a little bit of the history. So the history of heating homes. So as far back as 200 or 2,500 years ago, we've positioned housing designs to optimize solar energy. Housing was built with thick walls, which kept a home warm in the winter and cool in the summer. So only local fuel was typically available, so we weren't able to transport it in the same way as we can now. As housing has evolved over time, these elements, utilizing solar energy, constructing thick walls, and using local fuel, remain the same. And that was until the development of fossil fuels. So in the 1800s, the introduction of fossil fuels, of course, changed the way we heated our houses. And because houses could be heated by fossil fuels, we were less reliant on that solar energy, that need for thicker walls. And to this day, Canada's residential sources continue to be electricity, natural gas, and other fossil fuels, which have a substantial impact on our environment. So the typical energy use, if you broke down household energy use in BC, as you can see, the majority of energy, about 64%, is going to heating and cooling the house. Now, the average household in BC Hydro service area, BC Hydro, accounts for about 11,000 kilowatt hours per year at, let's say, 13 cents a kilowatt hour. It can be quite expensive, and we don't need to be there. So There's nearly 1.7 million residential hydro customers in BC. That means British Columbians are spending over $2.4 billion a year on energy. So how can we improve that? And there's a specific and real risk and impact with the communities in BC that are off-grid, that are run off diesel generation, as we know. So there's 86 remote or off-grid communities in BC. Many of the communities rely on diesel to produce power, which costs on average, let's say 37 cents or even higher to fuel. So diesel fuel generators are the cause of many concerns, including producing substantial greenhouse gas emissions, which can contribute to health problems in the community and are harmful to the environment. Diesel is a high cost. Cold northern locations require more heating, which contributes to very high energy expenditures. And diesel is a non-renewable resource. So in this case, Yale is not an off-grid community, but was still experiencing very high per month energy consumption to heat those BC boxes. So what's the impact, overall if we built a better house? In 2013, BC households were responsible for 4,374 kilotons of CO2 emissions. That's a lot. It's equivalent to about 920,082 cars driven for a year. It would take an additional 11.2 million tree seedlings to grow for 10 years to offset this. We're committed to reducing GHG levels by 30% by 2020, and a lot of it has to do with the solutions we can find in the home. So at Britco, we're not against energy, but we see the importance to reduce the need for energy. So along comes the passive house solution, and it has a significant impact on reducing our demand for energy. So what is a passive house? One option is to reduce the household energy consumption is to build a multi-unit residential housing to passive house standards. And that's what we've done with Yale. Passive house standards are an internationally accepted standard for energy efficiency in a building with a key set of criteria. So buildings built to these standards require very little energy for heating and cooling, and they must be approved and certified by a certified passive house consultant through rigorous testing. Now at Britco, we've got 3 in-house consultants, and I've got Tom Palashewski, who's our manager of special projects, who is a passive house design consultant and architect. He's actually on the line with me or listening in, and he'll be able to answer any questions as well that you may have over the discussion. But the first passive house was built in Canada at Lost Lake in Whistler, right around the Olympics. The building was originally built for the Olympics and was the Austria House, and it was a TV broadcasting studio for Austria. So it's quite interesting. The building was currently used as a day lodge, office, and meeting space for the Whistler Off-Road Cycling Association and Whistler Nordics, as well as location for cross-country skiing and mountain biking and a rental business. So over the first year performance, tracking the building's performance, it consumed less than $234 worth of energy for heating and cooling loads within the building. That's approximately 93 cents per meter squared per year. The average Whistler single-family home would consume more than $5 worth. In order to achieve these results, a passive house must adhere to rigorous principles and testing. So, here are some of the key criteria. To achieve passive house standards, increased insulation is key. Between 3 to 7 times better insulation performance is required when compared to current national provincial building codes. Regular inner insulation is used in addition to layers of outer insulation. Airtightness. By ensuring the airtightness of the building, you are minimizing the heat loss from air infiltration and protecting the building structure against possible moisture damage. Testing for airtightness is very challenging when traditional construction is used. Modular techniques allow for the airtightness testing to occur in the factory in a controlled environment, which is quite an advantage when you're trying to build these correctly. No thermal bridges. As you can see from the image, you see the regular photo at night, and then you see the night with infrared camera, you can see those yellow lines where the floors and walls are, where there is thermal bridging, and that occurs through the walls, foundations, and concrete balconies. As you can see from the heat map, there's many thermal bridges that lead to heat transfer, and as a result make the buildings incredibly inefficient in terms of heating and cooling. Passive design prevents the high heat transfers between construction materials through penetrations and gaps between insulation. We eliminate thermal bridging, and by alone reduces energy use by 4% when compared to buildings with thermal bridges. Advanced windows are also key. So triple glazing is used to retain the heat on cold nights and to minimize interior cold spots and downdrafts. And that's a really simple addition. Just buying a triple glazed window to any home makes a huge difference. And the other part is solar orientation of the home. Again, like we used to do 2,500 years ago, we really take into account how we place the home and interact when the windows interact with the winter and summer sun. It enables the building to have the maximum access to the sun when needed, or has the shading when needed. So the best solar orientation for a building varies by location. And that's again why you need your passive house design consultant to really figure that out and do it properly. And last but not least, we also have heat recovery ventilation. So the heat recovery ventilator produces superior indoor air quality and heat recovery, but heating the incoming air at the same time. So it exchanges the cool air from outside with the hot air from inside, but exchanges the heat with the inside air before the cool air from outside comes in. And that just makes a huge amount of sense. And the other part is the efficient building shape. Minimizing the building surface area is instrumental to achieving exceptional energy efficiency. The most ideal shape is a cube, since cube shapes have a lower surface area to volume ratio, making them more efficient than complex shapes. So as you can see in the picture, although each of these designs have the same floor area, the perimeter lengths are very different. And so we take that into account into our design, as you'll see what we've done with the Yale First Nation. So to achieve passive house standards, the following requirements must be met. The space heating energy demand is not to exceed 15 kilowatts per hour per square meter of net living space, and that's treated floor area per year, or 10 watts per square meter on peak demand. In climates where active cooling is needed, the space cooling energy demand requirement roughly matches the heat demand requirements, but with a slight additional allowance for dehumidification. The primary energy demand is the total energy to be used for all domestic applications. Heating, hot water, and domestic electricity must not exceed 120 kilowatts per square meter of treated floor area per year. In terms of air tightness, a maximum of 0.6 air exchanges per hour at 50 pascals pressure, and it has to be verified with an on-site pressure test in both pressurized and depressurized states. So it gets quite down to the details. If you don't pass, you don't get passive. The thermal comfort must be met for all living areas during winter as well as summer, with no more than 10% of the hours in a given day, or hours in a given year over 25 degrees. So when we apply modular techniques to passive house, it takes a lot to achieve those standards. So with our modular construction system, we can find some efficiencies because of our climate control and high focus on quality in our processes. When it comes to design, we're very detailed on our drawings, and there are high detailed requirements for passive house standards. And as a modular construction company, we were already there in the very detailed drawings. So whenever we're building using modular techniques, we start with the very detailed drawings and designs, and opposed to traditional construction methods, which may commence before designs have even been finalized. We don't hit the factory floor until we've got everything down on paper. And our quality control is quite high. The level of quality control that that can be achieved in a factory setting far outweighs that of on-site construction due to the controlled environment and repetitive work that we can put into the process. The in-factory testing is quite important. Building in a factory allows our passive house testing to happen as the modules are being built. Deficiencies, particularly for airtightness, can be caught nearly as they happen, which prevents rework and just increases that quality. We reduce our timelines. Now, it's estimated that the Yale Passive House would have taken over a year to complete using traditional on-site construction methods. Using the modular construction process, we reduce this to 5 months, and that's including building while we're building on a factory. So while the modules are being built in the factory, site preparation and work is being done at the same time. We also reduce the local labor requirement. Now, this can be a positive or a negative depending on how we want to work with communities to help build local talent and maximize what they've got, and we're very flexible to that. But with traditional site-built construction, many tradespeople may not be available in certain locations, which means builders have to transport and house them for the duration of the project, which can get quite expensive. So by building the modules within our factories and transporting them to the site, the need for local labor or relocated labor force is drastically reduced. And that also reduces a lot of the risk to the project too. As you can see from the weather we're having lately, we can overcome weather issues. As you can see on the foundation design, we hit a bit of a patch of a couple snowy days like we have now. But as you'll see in the next slide, we hit lockup pretty quick because we set all the boxes and got lockup within 2 days. So we don't have a lot of moisture or weather issues on our construction projects because they come to the site already built and sealed with weather protection. And we have minimal time on site. As you can see, once the foundation was done, we were setting the boxes on the foundation, and just in 2 days later, we had them all set. And so in conclusion, the Yale Passive House took only 5 months to complete from start to finish, and I'm saying the finish will be just the end of this month, which will be Canada's fastest built passive house, next to the first one we did in Bella Bella that took 7 months. And so we're finding efficiencies with every project that we do. It's 80% more energy efficient, emits 80% less greenhouse gases. It's going to achieve air tightness metrics of 0.6. And on the coldest night of the year, each unit in the passive house will require a heat load of just 6 100-watt light bulbs. And so the off heat from the light bulbs, your body heat, and the appliances that you use in your home, like your stove, your fridge, your TV, all provide enough heat to keep the unit. And I suspect members living in those units will never have to turn on their baseboard heaters to heat their units. And what's most important as well is that our project is being delivered on time and on budget to make sure that we deliver Crystal and the rest of the community just a wonderful project that they know we can do again and again. So what's next for the Yale First Nation and Britco? I'll leave you with this. This is the design and rendering of a fourplex that we're building right now in the factory. And we're just incredibly excited for the partnership and the long-term relationship we've created with the Yale First Nation. Thanks to Crystal and Chief Hansen. And with that, I thank you. Thank you so much.
Well, thank you so much, Colin and Crystal. So at this point, we're going to move into our Q&A session. I see there's a few questions that have already popped up. Before we get into the questions, and to give people some time to do a little bit of thinking of what they'd like to ask, I'm just going to launch a poll to see what type of representation we have in our audience today. We can take a few minutes to answer this poll. All right, well, thank you for filling in our poll and looking at our results. It looks like we have the most representation from First Nations administration, as well as some from local and regional governments, consulting, non-government, and a few from First Nations Council. So moving into our questions, the first one that we have is whether the structures meet the Region 8 or 7B of BC Building Code energy standards.
Yes, so Colin here. So yes, they exceed them.
Thank you. And another question directed towards Colin. If you can give us a bit more detail about the Yale project, about the nature of the project and specific issues that were encountered and overcome.
Well, because of the nature of the modular construction process, we try to go through every single detail before we put a shovel in the ground. And we take prime on the relationship, and so we have project managers that oversee things and try to see issues before they come up, and so they don't become issues. So we do a deep analysis on what the site looks like, what the servicing looks like, you know, the geotech on the land to find out what kind of foundation we can put down there, informing the foundation design, of course. And from there, then we just build the rest of it in the factory. And if the foundation meets the measurements that we put down in the drawings, then we can set our boxes right on top, and we deal with everything in the factory for the most part. That anything goes vertical, that we deal those issues right away in-house. But because we go to the factory with detailed construction drawings before we put a nail to any kind of piece of wood, it de-risks any issues coming up at all.
Great, thanks, Colin, for those details. I can see we have a few questions related to costs for the project. The first one is, what were the transportation costs? The cost of the fourplex. It's questions about the cost per square foot for construction as well.
So building to a passive house standard is a higher cost because of those additional materials. And so a typical construction process, it's about, to answer the first question, it's about $2,000 per unit per transportation to the site with Yale. And that depends on how far our factory is from the location we're building. And that's variable across the board. There are some units that that it costs quite a bit more to take it up to Dees River or something like that as well. So the total cost of the fourplex is $640,000, and the cost per square foot typically is sitting anywhere between $200 to $233 a square foot.
Mm-hmm. And knowing these costs, a question for Crystal is, how did the band fund the project?
So the sixplex that we were just looking at was funded through CMHC, Section 95 housing. However, the band did have to contribute approximately $300,000 of our own funds to the project to make it a reality. As most people are aware, CMHC funds $167 per unit, and these units were approximately $200,000 each. So it was about an overrun of about $50,000 per unit that the band had to contribute. We look at it as an investment in the future of the band. We look at it as leading to long-term savings. So for us, it's a very good investment. The fourplex was funded completely by through INAC, through Budget 2016, and the cost of that unit was completely within the funding guidelines given to us by INAC.
Okay, thanks, Crystal. So another question for you is that, oh, sorry, I misread this. It's for Colin. Is Yale First Nations your only project so far, or if you've had others, how has energy performance been in other projects?
So the other building we have is in Bella Bella, which is very similar to the sixplex that you saw in the designs that we're building with Yale, and the building is performed incredibly well. I think it's even heating up quicker than what we thought in the original designs, because there's more appliances and computers than we originally put in for our calculations, and it's continually being tested, and it's on track so far to meet what we thought it would.
Sounds great. And some logistical questions. What type of foundation was used for this project? And then how many lots were used for this project?
We built the lot, we built on the same lot that we had a single house on. So I don't know, I can't tell you acreage or anything like that. I think it's a pretty typical, maybe half-acre lot.
And yes, the foundation was concrete, and it was a 4-foot crawl.
Another question regarded in relation to costs is whether setup costs are included in the price that you had previously mentioned.
Yes, so if you bring the service lot, so the service is to the lot line and everything's cleared, that's typically the price, but it all depends on what the geotech report says about the lot itself, and what the foundation design would look like, and also the transportation costs.
Mm-hmm.
I should also mention as well, from the band's point of view, I've actually managed new construction before. I built 6 homes for a neighboring First Nation, and it seemed like we were writing, you know, a dozen checks a day, little things. With Britco, we write 3 checks. That's it. We write a check for the down payment. We write a factory completion check, and then we write final completion check. So 3 checks. We knew exactly to the dollar what this was going to cost us right at the beginning. We did have, I have to admit, we did have a cost overrun of about $2,000 because I had made an executive decision to not have carpeting upstairs in the units. And so we removed the carpeting, we had to put in some flooring, and we also had to replace the stairs because the stairs, of course, were to be carpeted. So we decided to do a pine tread with a coating that has walnut husk in it so that they weren't slippery. So it added on about $2,000 to our budget, but we knew that right away. So there were no, you know, scary surprises with the project. We knew what to expect.
That's good to hear. Another question from our audience mentions that this project illustrated electric heat, but can natural gas or wood be used?
Well, I think that with the whole passive house design and the energy performance that you'll realize for each unit, you won't need an alternative energy source. Really, the electric baseboard heating is just a backup that most likely will never be turned on. And that was the experience in our previous project with Bella Bella. Just because the off heat from the light bulbs, the appliance heat, and your body heat really is enough heat to heat the units. And so if you use an alternative source, I think it'll create too much heat for the unit. that's how efficient these buildings are.
Mm-hmm. Thanks, Colin. There's a question for a clarification on what a thermal break is. I know you mentioned it in your presentation, but could you just explain it further?
I'm sorry, I didn't hear the question.
Oh, sorry. So the question is asking for more clarification on what a thermal break is, whether it's a source of heat loss or if it includes a, a moisture problem as well.
So if you have a thermal bridge, that's where, yeah, you have automatically, as you can see, if you remember from that infrared image, it's yellow, it's very, very hot, and so you have a heat loss, but you also get condensation at those thermal bridges, at those points, and so where you get condensation, you get mold. And so with a thermal bridge, you get an issue like that you just try to avoid those summer bridges because you will eventually get condensation and eventual mold issues.
And one audience member is asking for you to describe in more detail how the modules become connected.
That's the fun part. We build the modules in the factory to as you know, ultimately be connected. And so we have points of junctioning for all the different cabling and plumbing, and then it's basically just, you know, for all intents and purposes, big boy Lego, you fasten them together on site, and the structures are built with those fasteners and those basically bolting them together with different spots on each part of the floor and ceiling, and that's basically how you do it.
Great. There's a question here for Crystal about whether she would highly recommend passive houses. This person has applied for 3 duplexes. They currently live in steel framed homes that were poorly insulated with their negative 30-degree weather. People are burning through their wood quickly. Is there something similar to the passive homes with a more reasonable price range?
I'm really sorry. Your voice is very muffled. I'm having a hard time understanding what you're asking.
Okay, sorry about that, Crystal. I'll try to speak a bit slower. So this audience member is wondering if there's something similar to passive homes at a lower price range that you know of.
Not that I know of, but we are putting energy efficient processes into our older homes as well. We're just trying to do our best to tighten up that envelope to make those homes more airtight. There are options available. I don't know about cost effective. I know that there are new solar shingles out that you can apply just like regular shingles, and they will harness the solar energy for the homes. That's something that you can think about for some of your older homes when you're doing renovations. From what I've found through research, you know, good builds aren't cheap, and cheap builds aren't good. So if you're going to do it, you need to do it right, and you need to find the money to do that.
Mm-hmm. Oh, you mentioned solar as an option, Crystal. Have you used solar at Yale First Nation?
It's something that we're looking at now, and it's something that we'd really like to combine with our passive housing. Everything that I've heard from Colin and talking to Tom as well is that it's a beautiful combination, combining solar with passive technology. You can achieve net zero if that's what you're looking for.
Mm-hmm. There's a question here on, I'm not sure if it's directed to Crystal or Colin, on someone who's doing a monitoring and energy performance study, and whether they would be doing a cost comparison study on the sixplex in Ruby Creek Reserve.
Yes, absolutely. We'll be monitoring our energy results for the next year or two. I'm also looking for some funding right now so that I can actually buy some equipment, some specialized equipment to monitor and collect that data.
Yeah, and our engineering firm, which we contracted by the name of RDH, will also be doing that as well.
Sounds great. In your presentation, you talked about how there is more limited labor on site, but were there opportunities to incorporate some labor from the band?
Yes, on certain scenarios where we have the talent from communities, yes, there is. And in fact, in our factory in Agassiz, we have about 10% of our workforce come from different First Nation communities around our area, and which is also quite wonderful.
And we have some employment opportunities available as well for our band members. In the finishing phases of the project, doing the landscaping, getting the parking lots ready for our tenants as well.
And actually, the other thing too is we're working on a course supported by a private post-secondary institution to get a modular construction site course taken care of, so we can start training folks from different communities to have the skills to put all our modules together on different projects. But of course, it didn't come in time for this project, but we're hoping for every subsequent project.
That sounds really interesting to know about this course development. I know we just have a few more minutes left, so I'll try to get through a couple more questions. One thing I wanted to ask Crystal is we had talked previously about a First Nations housing manager network to build capacity for First Nations housing managers. Could you give us a little bit more detail about that?
Yeah, sure. So through budget 2016, there was some innovations funding that was available specifically for mentoring. So Yale First Nation applied for that funding and was successful in receiving that funding. And so we're heading up the BC First Nations Housing Mentorship Program. And this is to gather up those First Nations who are really floundering, who don't have the internal capacity to, first of all, set up a housing department or to administer it effectively, people who need help with their policies or setting up their files or figuring out the processes for accessing funding, knowing what reports to have in ahead of time, knowing what types of organizations they're going to be needing to deal with, etc. So the mentorship program will really be serving those bands who have high turnover in their housing staff, who have young students working as their housing managers, people who need that one-on-one support. So there's 3 ways for those bands to access assistance. One is in person. So we'll be hopefully matching First Nations with housing staff in their area, or at least as nearby as possible, who can mentor them in person, who can go in and show them person to person how to set up their files or how to access the funding or assist them with applications and templates and resources. People can also access resources and support by telephone, and I've already had a good 24 bands contact me looking for templates and tools, and then also online. So the website is being developed right now. There will be a library, a resource bank that First Nations staff and managers can access for tools and templates. Also links to organizations such as Not Samat, who has their new housing policy toolkit that they're just launching. But also there will be online discussions with anybody from housing inspectors to contractors to passive house professionals. Anybody, if they're looking for particular information, they can make requests, and the housing mentorship program can line up those resource people for them to connect with. So it's really just forming connections and putting people in touch with the resources and tools and information that they're going to be needing for their own housing departments.
All right, well, thank you so much for telling us more about that upcoming program. I'm looking forward to hear more about it as it develops. I recognize that it's 12 o'clock right now, and I know that there are more questions that were asked that we weren't able to get to. I'll be compiling these questions together and touching base with Crystal and Colin to see if we can provide some responses after the webinar. So thank you to all the participants this morning for listening in and for your engagement in our Q&A session. And a huge thanks to Crystal and Colin for providing their time and doing this presentation and for being with us this morning.
Thank you.
Thank you so much.